So for this video, we will be looking at solving systems of linear equations using determinants of a matrix. In the previous video, we tried to solve systems of linear equations using the process of elimination. Now, we will be using the determinants of a matrix or the matrix as a means to solve systems of linear equations. As you can remember, matrix, as we discussed before, is an array of a rectangular array of numbers. And you'll be using this array of numbers in order to solve for the values of x, y, and z of a given system of linear equations. By the way, we will be dealing with linear equations in three variables. So here are the steps for solving the systems of equation using the determinants of a matrix. So first is we have to arrange the given equations in the form of ax plus by plus cz equals d. So if in case any linear equation is not arranged in this way, just simply rearrange the terms. No need to change the sign unless you have to transpose it to the right or to the left side of the equation. Next, identify values of a, b, c, and d and take note of their signs. Remember, a is the coefficient of x, b is the coefficient of y, c is the coefficient of z, and the one that is a constant number, which is after the equal sign, is called the d. Next is we list down all required values to solve for d, dx, dy, and dz. So what do we mean by these symbols? D means determinant, dx means determinant of x, dy means determinant of y, and dz means determinant of z. In order for us to solve for the determinant, we have to subtract the sum of the products of the right to left diagonals from the sum of the products of the left to right diagonals. Remember to be careful with your operations. Later, I will illustrate to you what's the right to left diagonals and what are the left to right diagonals. Next, we follow the formula in solving for the values of x, y, and z. And remember to check your answers by substituting the values of the variables to all original equations. This is to ensure that your answers are correct. Note that if, for example, there's in the equation, there's a missing term. For example, y is not there. Then you just have to supply y with 0 as its numerical coefficient. So let's try to apply these steps in the given example. So I have here the system of linear equation 2x plus y minus 3z equals 7, x minus y plus 5z equals negative 11, and negative 2x plus 2y minus z equals 4. Okay, so the first thing that we need to do is to ensure that all terms are or all equations are written in ax plus by plus cz equals d. So let us look at that. So here, this one is arranged as x plus y and then z and then d. D is the constant. X, y, z constant. X, y, z constant. Okay. So we're done with step one. Step two is we have to identify the values of A, B, C, and D, and we have to take note of their signs. Now, these values of A, B, C, and D will now form the part of our augmented matrix. So we will now write this system of linear equation into an augmented matrix. So this is now the augmented matrix. All the A's will be written in one column, all the B's and the C's and the constants or the D's. So we have here 2, 1, negative 2. Again, we are getting the coefficients of x because this is A. The coefficients of y are B, are the B's. The coefficient of z are the C's, and then the constants are the D's. So I will continue writing. So we have 2, 1, negative 2. For the B, we have 1, negative 1, and 2. And for C, we have negative 3, 5, and negative 1. Now, since we're now at the part of the D, I would draw a vertical broken line, and then I would write 7, negative 11, and 4. This is what we call the augmented matrix. Augmented because we are writing the variables x, y, and z and then joining it with the constants after the equation sign. Okay, so we're now done with step 2. Now, let us now solve for let us now solve for the determinants. And according to our steps, we have d, dx, dy, and dz. Let us first solve for the determinant of d. So how do we solve for the determinant of d? So here's what I want you to do. I want you to cover, in the monitor, the D part. So I will just write it here as a guide. This is A, B, C, and D. I want you to cover the column of D. So if you cover all the columns of D, because we're looking for the determinant of D, what remains will be the matrix having the columns of A, B, and C. Okay? So our this will be the composition of our matrix that can solve for the determinant of D. So again, in your monitor, cover the column of D, and what you will see or what will be left are the numbers or coefficients for A, B, and C. So I will write it here. I will write the determinant, the numbers that will take form the matrix of T, and we have 2, 1, negative 2, 1, negative 1, and 2, negative 3, 5, and negative 1. And then what are you going to do? The next thing to do in order to solve for the determinant, okay, when you solve the determinant, this is the step. Okay, I'll just erase this one. So in order to solve for the determinant, always remember to copy the first two columns of the matrix. So in this case, the first two columns are the columns A and B. So I will copy the numbers there, 2, 1, negative 2, 1, negative 1, 2. And then this is the time now that we will apply the next step, which is subtracting the sum of the products of the right to left diagonals from the sum of the products of the left to right diagonals. So what we will do now is to multiply all the numbers in the matrix that are parts of the diagonal. I will use the blue pen. Okay, so this one, that's one diagonal. This is another diagonal, and this is the last diagonal. So what we will do is we multiply all the ones in the line, in the diagonals, and then all the sum from the left to the right, we will add. So I will have here, determinant would be 2 times negative 1 times negative 1. That's the first diagonal. Okay? I will add that to the numbers or the products of the second diagonal. 1 times 5 times negative 2. And then I will add the product of the third diagonal. Negative 3 times 1 times 2. Always remember that you have to be very careful in writing the digits and to not forget to write the signs of the numbers. Or else, if you make a mistake in one, then a lot of the steps will be a mistake already if you continue doing it. Okay? So now let's go to the other set of diagonal. I will now use the red pen. This is now the left to right diagonal. So we will now subtract. I will put the minus sign there. And we will subtract naman the products of the diagonals from the left to the right. Okay? So I will put a bracket here. Why? Because there's a negative sign beside it. So I have to make sure that I will be able to multiply that before I subtract it. So I have to put a brace there or a bracket. So let's multiply the first one. So we have negative 2 times negative 1 times negative 3. Again, I add the product of the numbers in the second diagonal, 2 times 5 times 2. And then add the product of the third diagonal, negative 1, 1, and 1. Negative 1 times 1 times 1. Then I'll close it using the bracket. Okay. Let's now simplify. Let us further simplify our answer. So we have here 2 times negative 1 times negative 1. That gives us positive 2. 1 times 5 is 5 times negative 2 is negative 10. Negative 3 times 1 times 2 is negative 6. Minus, again, the bracket. Negative 2 times negative 1 times negative 3 is negative 6. 2 times 5 is 10 times 2 is 20. And the negative 1 times 1 times 1 gives us negative 1. Further simplifying, 2 minus 10 is negative 8. Negative 8 minus 6 is negative 14. Minus the bracket again. Negative 6 plus 20 is positive 14. Minus 1 is 13. So D is equal to negative 14 minus 13, and then the determinant of D is negative 27. So we already have an answer for the determinant D, and that is neg that is 20 negative 27. So I'll just put a rectangle here. I'll put it inside the box so that we will not miss it later. So we're done with D. Let's now go to D and X. Okay, so dx. Let us now solve for the next for dx. Okay, so remember what I told you a while ago when we were trying to solve for D is we covered the column where D is located. Okay, now for dx, we remember that the coefficient for x is a. So at this point, what I want you to do is to cover the column of A and then replace it with the numbers in D. That means I will remove A, but I will replace the numbers in A with D. So what will now be our matrix? So with that, our matrix would be 7, negative 11, and 4. So I will put it here. So the first is 7, 11, and 4. That is based, oh, negative 11. That's based on our coefficient here. Okay. And then, so this means it's D, B, and C. D, B, and C. So we will copy it that way. B is 1, negative 1, and 2. So B is 1, negative 1, and 2. And I will copy here. 1, negative 1, and 2. And then C is negative 3, 5, and negative 1. Sorry. Negative 3, 5, and negative 1. Negative 3, 5, and negative 1. Let us double check because I don't want to make any mistake. It's 7, negative 11, and 4. 1, negative 1, and 2. and negative 3, 5, and negative 1. Okay, so same thing. Again, we have to copy the first two columns. So the first two columns are 7, negative 11, 4, 1, negative 1, and 2. And then we begin multiplying the diagonals. So I have here dx would be equal to the first diagonal, which is 7 times negative 1 times negative 1. I add to the second diagonal, which is 1 times 5 times 4, adding the third diagonal plus negative 3 times negative 11 times 2. Subtracting to the upper diagonals, I'll put a bracket again. So first diagonal, we have 4 times negative 1 times negative 3. And then the second diagonal plus 2 times 5 times 7. And then the third diagonal, which is negative 1, negative 11, and 1. So 7, negative 1, negative 1, 1, 5, 4, negative 3, negative 11, 2. And then 4, negative 1, negative 3, 2, 5, 7, negative 1, negative 11, and 1. So let us now simplify. So 7 times negative 1 times negative 1 is positive 7, plus this one is 20, and then this one is 33 times 2, which is positive 66, minus, and then the bracket. 4 times negative 1 times negative 3 will give us positive 12, plus 10 times 7 is 70, plus 1 times 11, negative 1 times negative 11 times 1 is positive 11. So simplifying further, we have 27 plus 66, which is 93, minus the bracket. We have 12 plus 70 plus 11, which is 93 also. So we now simplify. Dx is 93 minus 93. That is 0. So this will now be the value of our dx. Now we'll do the same process again, and this time for dy. So since we're now solving for dy, we will now cover the coefficient for y, which is b. So I will cover b and then replace the numbers in b by the numbers in b. So, therefore, what will be our pattern if that's the case? So, I'll start with A, and then B will be covered, and then it will be replaced by D. So, A, B, C. That will be the things that are the columns that I will be copying. So, let's go and see what the numbers are. So, A is 2, 1, negative 2. 2, 1, negative 2. Then we have D, 7, negative 11, and 4. And we have C, which is negative 3, 5, and negative 1. Negative 3, 5, and negative 1. Again, we copy the first two columns. So we have 2, 1, negative 2, 7, negative 11, and 4. And then you will now start multiplying the diagonals. So let's start here first. We have 2 times negative 11 times negative 1 plus second diagonal 7 times 5 times negative 2 plus the third diagonal, that's negative 3 times 1 times 4, minus, and then the bracket. First diagonal, negative 2 times negative 11 times negative 3 plus the second one, 4 times 5 times 2 plus negative 1 times 1 times 7, and then close bracket. Let us further simplify. So the first, this one is 2 times negative 11 times negative 1, which is positive 22. And then we have minus 7 times 5 is 35. 35 times 2 is 70. So minus 70 because positive, positive times negative. And then here also minus, which is negative 12. Minus, and then the bracket, negative 2 times 11 times 3 gives us 66. So it's negative 66 plus 20 times 2 is 40 minus 1, negative 1 times 1 times 7 is negative 7. Now let us simplify further. Then we will have 22 minus 70 minus 12 gives us negative 60 minus, we have negative 66 plus 40 minus 7. That gives us negative 33. So if we multiply the negative to the negative sign, it will become negative 60 plus 33. And we will have the answer of negative 60 plus 33 dy is equal to 27. Oh, sorry, negative 27. So I'll put a rectangle here. Okay, now, so we're now done with d. We're now done with dx and then dy. And the last one is solving for dz. Okay, so this is the last determinant. So we are now solving for dz. And in order for us to solve dz, we have to cover the c part because it's the coefficient of z, and then replace the column of c with the numbers in d. Therefore, our pattern will be A, B, D. So let us copy the columns A, B, D. So A is 2, 1, negative 2. Oops. So DZ is 2, 1, negative 2. B is, from our augmented matrix, B is 1, negative 1, 2. 1, negative 1, 2. And for D, that's 7, negative 11, 4. And again, we copy the first two columns. So that is 2, 1, negative 2, 1, negative 1, 2. And then we start multiplying the diagonals. So let's have the first diagonal. 2 times negative 1 times 4 plus second diagonal 1 times negative 11 times negative 2 plus the third diagonal, which is 7 times 1 times 2 minus the next diagonal. So upper naman, when you go up, so negative 2 times negative 1 times 7 plus the second one is 2 times negative 11 times 2 and plus 4 times 1 times 1. Okay. So let us simplify further. So this, the first term is negative 8 plus 22 plus 14 minus, we have negative 2 times negative 1 times 7. So that's positive 14 minus 44 plus 4. So let us simplify more. So we have negative 8 plus 22 plus 14, which is equal to 28, minus, we have 14 minus 44 plus 4, which is negative 26. And so if we distribute that, dz will become 28 plus 26, and 28 plus 26 is 54. Therefore, dz is equal to 54. So this is now the determinant of z, or dz. Now we're not yet done. We have just solved d, dx, dy, and dz. And according to our steps, if we just go back to our steps previously, according to the steps, after we find the different determinants, we have to follow the formula in solving for the values of x, y, and z. And this is how, and this is the formula for x, y, and z. I will write it here. X, oops, sorry. X is equal to dx over d, y is equal to dy over d, and z is equal to dz over d. Meaning, after we have solved for all the determinants, in order to get x, y, z, we have to divide determinant of x by d, determinant of y by d, and determinant of z by d. So let's do that. So again, the values that we got, so I'll just summarize, summarizing the values of the determinants. So we have d, which is equal to negative 27, dx, which is equal to 0, dy, which is also equal to, let us check, negative 27, and dz is equal to 54. So if we want to solve for x, we follow the formula dx over d, which is equal to 0 over negative 27. Hence, x is equal to 0. Next, if we want to solve for y, that is dy over d, which means it's a negative 27 divided by negative 27. Hence, y is equal to positive 1. And if we want to solve for z, the formula is dz over d, which is equal to 54 divided by negative 27. Therefore, z is equal to negative 2. So as our final answer, we will write the solution set. Always write the solution set in braces in the format x, y, z. So x is 0, y is 1, z is negative 2. Now, the last step says that we have to check. We have to check if our answer is correct, or if our answer makes the three equations true. So allow me to write again the equations that we have. We have 2x plus y minus 3z equals 7. X minus y plus 5z equals negative 11. And negative 2x plus 2y minus z equals 4. So let's check if x is 0, y is 1, and z equals negative 2 satisfy each equation. So let's start first. I'll write equation 1, 2, and 3 here. So let's start first with equation 1. So we have 2x plus y minus 3z equals 7. So is 2 times 0 plus 1 minus 3 times negative 2 equal to 7. So let's see. This one is 0. This is 1 plus 6. Yes, it's equal to 7. So check tayo sa first one. Let's go to equation 2. X minus y. plus 5z equals negative 11. So x is 0 minus 1 plus 5 times negative 2. Is this equal to negative 11? So we'll have negative 1 minus 10, which is equal to negative 11. So we have another check mark there. It makes the equation true. And let's go to equation number 3. We have negative 2x plus 2y minus z equals 4. And will negative 2 times 0 plus 2 times 1 minus negative 2 be equal to 4? So this one cancels. This is 2 plus 2, which is equal to 4. Therefore, we now accept our solution set. That is x is 0, y is 1, and z is 2. And that is how you solve a system of linear equations using determinants of a matrix.